Hi everyone, myself Palakshmi worked as a STEM professor in the Department of Mathematics, Government Science College, Chitradurga. So in this class, first I would like to discuss the syllabus of first semester mathematics in Davangere University. So and later after that I start the related topic. Okay. First, so your mathematics syllabus consists of 6 units. In first units, in the first part, so totally we divide that one into two parts. One is the algebra and another one is the calculus. In algebra 1, that first unit is related to matrices. In this one, we discussed symmetric, skew symmetric matrices, elementary operations on matrices, rank of a matrix, inverse of a matrix, of a non-singular matrix by elementary operations, system of m linear equations in n unknowns, matrices associated with linear system, criterion for existence of non-trivial solutions of homogeneous system. So in this one, I think some of the topics are old one. You already studied what is symmetric matrix, Q-symmetric matrix in PU classes. So and that new concept is rank of the matrix and finding the inverse. I don't know in which method you are finding the inverse, but here we are using by applying elementary row operations, we find the inverse of matrices. After that, we discuss the solution of non-trivial solutions of homogeneous systems. So here we are not discussing the non-homogeneous. So in this syllabus, it consists of only homogeneous systems, solutions of homogeneous systems. So and in the second unit, we discussed that eigenvalues and eigenvectors of a square matrix, and after that, matrix and properties. There are reductions of such matrices to diagonal form. So we find the diagonal form by taking the help of eigenvalues and eigenvectors. And in third unit, it is purely algebra groups part. I think you studied that. Binary operations concepts and some of the properties on binary operations in PU classes. So here it is the improved part of that. Here we discuss the groups. So basically group is a set with some specific properties. So in this third unit, we discussed that properties, problems on finding identity, inverse, and definition of a semi-groups. Semi-groups concepts also discussed here, and abelian group. So abelian group is a group with extra one property. So and finite and infinite groups. Properties of groups with standard problems on groups. A finite semi-group with both the cancellation laws is a group. Some of the properties like that, and subgroup concepts also discussed, and permutation groups also discussed in this third unit. And unit 4 consists of calculus part. So that is differential calculus. In differential calculus, you already studied the limit continuity part in PU classes. So here once again we discussed in depth that continuity and differentiability concepts and some of the properties like a function which is continuous in a closed interval is bounded, attains its bounds, takes every value between its bounds. So that type of properties we are discussed here. And after that, the differentiability and continuity implies continuity. So that type of topic is discussed in this one. And in next unit, it is unit 5. In unit 5, it is a successive differentiation. Successive differentiation. You already studied differentiation concept, derivative of a function. So it is the improved part. So here we find second and higher order derivatives. So of the some standard functions like ax plus b to the n, log of ax plus b, e to the ax, sine ax plus b, cos ax plus b, and so that nth derivative of some product is found out by taking the help of Leibniz theorem, and some of its applications are discussed here. And next integral, sixth unit consists of integral calculus. We already studied integrations. So you know what is the integration of sine x, and we know what is the integration of sine square x, and what is the integration of sine cube x, what is the integration of sine to the power 4x, what is the integration of sine to the power of 100th x. So We can easily within one step we can find all that values by taking the reduction formulas. Some standard reduction formulas are discussed here and its applications also in integral calculus part. This is your syllabus. So in this class I would like to discuss the successive differentiation. Successive, what is meaning of a successive differentiation? That concept I am discussed here. Yes, what is meaning of successive differentiation? So first you take one function. First I just wanted to remember some differentiation problems. So first you take one function like y is equal to y is equal to log of sin x. Log of sin x. You just go and differentiate this with respect to x. So differentiating this y with respect to x, differentiation of y is y1. So it is a function of function. So log consists of a function sin x. So first we have to differentiate log and after that that inside function. Differentiation of log x is 1 by x. Like that, differentiation of log sin x is 1 by sin x. 1 by sin x, and again we have to differentiate that sin x. Differentiation of sin x is cos x. Differentiation of sin x is cos x. So differentiation of y is y1. y1 is equal to cos x by sin x. Cos x by sin x is cot x. Cos x by sin x is cot x. So once again we can differentiate this y1. So if we differentiate this y1, it gives that differentiate this y1 with respect to x. Differentiation of y1 is y2. Differentiation of cot x is what? Minus cosecant square x. So differentiation of cot x is minus cosecant square x. So now I can differentiate that y2 also. So if you differentiate that y2, it gives y3. So if you differentiate this y2, what it gives? Differentiate with respect to x. Differentiation of y2 is y3. y3 is equal to minus is a constant. You keep that as it is. Differentiation of cosecant square x. So first we have to differentiate this power. So it is 2 into cosecant x. The differentiation of power is over. Next, the function which is inside that power. Power ಒಳಗಡೆ ಇರೋ function ಅನ್ನ differentiation ಮಾಡಿದ್ರೆ differentiation of cosecant x is minus cosecant x into cot x. Simplifying this, it gives that 2 cosecant square x into cot x. This is called the third derivative of y with respect to x. This is the second derivative of y with respect to x. This is the first derivative of y with respect to x. So that means the process of computing second and higher order derivatives. If you differentiate y3, it gives y4. Differentiate y4, it gives y5. So the process of computing second and higher order derivatives is called the successive differentiation. That is called the successive differentiation. So that is the meaning of successive differentiation. Successive differentiation means the process of computing second and higher order derivatives is called the successive differentiation. Suppose if you take one general function like y is equal to f of x. Y is equal to f of x is any function. It may be cos x, sin x, exponential, logarithmic function, whatever it may be. Now you differentiate this y with respect to x. Differentiation of y is y1 is equal to differentiation of f of x is df by dx, or you can write it is f dash of x, is called first derivative of y is called first derivative of y with respect to x. Again you differentiate this with respect to x. It gives y2 is equal to f double dash of x is called second derivative of y with respect to x. Again you differentiate y2 with respect to x. What it gives? y3. y3 is equal to f triple dash of x is called third derivative of y. Third derivative of y with respect to x is if you go on like this. So next you once again a differentiate this, it gives y4. After that it gives y5, y6. Like that we can find higher order derivatives. This is the successive differentiation. So up to where we can find, up to 100th order we can find, up to 1000, up to 10,000. You can take any number in place of that. So generally you write, so up to nth order we can find its derivative. So that is yn is equal to f n of x is called nth derivative of y with respect to x. Why we need the nth derivative? ಏನಕ್ಕೆ ಬೇಕು ನಮಗೆ nth derivatives? If you know the nth derivative, from that we can find the differentiation of any order. ನಮ್ಗೆ ಯಾವ್ದು ಬೇಕು ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು. 50th differentiation ಬೇಕಾ, 50th order differentiation ಬೇಕಾ, ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. 10th order differentiation ಬೇಕಾ, ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. n ಪ್ಲಸ್ ಅಲ್ಲಿ 10 ಹಾಕಿದ್ರೆ 10th order ಬರಬೇಕು, 100 ಹಾಕಿದ್ರೆ 100th order ಬರಬೇಕು. So if you find the nth order differentiation, from that we can find the differentiation of that function any order. Okay, so now I wanted to discuss nth derivative of some standard functions. ಕೆಲವು standard functions nth differentiation find out ಮಾಡೋಣ. Says here is the problem. Find the nth derivative of e to the power of x. It is an exponential function. E to the power of ax though nth differentiation find out ಮಾಡೋಣ. So now you take given function is, let y is equal to e to the power of ax. Let y is equal to e to the power of ax. If y is equal to e to the power of ax, you differentiate this with respect to x. Differentiation of y is y1 is equal to differentiation of e to the power of ax is e to the power of ax. Again the differentiation of ax is a, or differentiation of e to the power of ax is e to the power of ax into a. So it is very familiar result. Again you differentiate this y1, it gives y2. Differentiate this with respect to x. Differentiation of y1 is y2. y2 is equal to e to the power of ax. Differentiation is e to the power of ax into a. Already one constant a is there, so it is a into a. So that is y2 is equal to a square into e to the power of ax. Again you differentiate this y2 with respect to x. So then it gives y3. y3 is equal to a square is constant, keep constant as it is. Differentiation of e to the power of ax is e to the power of ax into a. So that is y3 is equal to a cube into e to the power of ax. If you go on continuing like this, finally at the nth stage we get yn, that is the nth derivative. So yn is equal to, how to generalize the result? By using this y1, y2, y3. So in y2 itself we can write the nth step, nth result. ಬಟ್ ನಮಗೆ ಸ್ವಲ್ಪ ಇನ್ನೂ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಆಗಲಿ ಅಂತ ನಾನು y3 ಕೂಡ ಬರೆದಿದ್ದೇನೆ. Okay, how to generalize this? It is very easy. So what number we are taken here? N. Okay, so if y3 is there, a has the power 3. If it is yn, a must has the power n. ಸೊ y3 ಇದ್ದಾಗ ಏನ ಪವರ್ 3 ಇದೆ ಅಂದ್ರೆ yn ಇದ್ದಾಗ ಏನ ಪವರ್ n ಬರಬೇಕು, n ಬರಬೇಕು. ಯಾಕೆ ಅಂದ್ರೆ y2 ಇದ್ದಾಗ ಏನ ಪವರ್ 2 ಇದೆ, y3 ಇದ್ದಾಗ 3 ಇದೆ. ಸೊ n ಇದ್ದಾಗ ಏನ ಪವರ್ n ಬರಬೇಕು. ಸೊ ಅದನ್ನ ಬಿಟ್ರೆ ಕಾಮನ್ e ಟು ದಿ ಪವರ್ ಆಫ್ x y2 ನಲ್ಲೂ ಇದೆ, e ಟು ದಿ ಪವರ್ ಆಫ್ x y3 ನಲ್ಲಿದೆ. ಸೊ ಕಾಮನ್ಲಿ yn ಆಲ್ಸೋ ಕನ್ಸಿಸ್ಟ್ಸ್ ಆಫ್ e ಟು ದಿ ಪವರ್ ಆಫ್ ax. So therefore nth differentiation of e to the power of ax is equal to a to the power of n into e to the power of ax. This is the nth differentiation of the function, standard function e to the power of ax. So again, similarly, find the nth derivative of one more function, that is a to the power of x. a to the power of x is, let us consider this function y is equal to a to the power of x. Let y is equal to a to the power of x. You can take this is 1. You differentiate this with respect to x. Differentiation of y is y1. y1 is equal to, what is differentiation of a to the power of x? Differentiation of a to the power of x is a to the power of x into log a. Again you differentiate this with respect to x. So y1, differentiation of y1 is y2. Log a is a constant. You keep log a as it is. Differentiation of a to the power of x is a to the power of x into log a again. So that is y2 is equal to log a whole square into a to the power of x. You can differentiate this again with respect to x. Differentiate y2 with respect to x. Differentiation of y2 gives y3. So log a whole square is a constant. Differentiation of a to the x is a to the x into log a. That is y3 is equal to log a whole square into log a is log a whole cube. Log a whole cube into a to the power x. This is the differentiation of y2, that is y3. So if you go on continuing like this, at nth step we have, at nth step we get that yn is equal to, so y3 ನಲ್ಲಿ log a ನ ಪವರ್ 3 ಇದೆ, yn ನಲ್ಲಿ log a ನ ಪವರ್ n ಇರಬೇಕು. ಯಾಕಂದ್ರೆ 3 ನಲ್ಲಿ ಇಲ್ಲಿ 3 ಇದ್ರೆ, so n ನಲ್ಲಿ ಇದ್ರೆ it should be n only. a to the power of x is common. In y2 also it is common. y2 ನಲ್ಲಿ log a ನ ಪವರ್ 2 ಇದೆ, y3 ನಲ್ಲಿ log a ನ ಪವರ್ 3 ಇದೆ, y ನಲ್ಲಿ log a ನ ಪವರ್ n ಬರಬೇಕು, along with a to the power of x. This is the nth differentiation of, therefore the nth differentiation of a to the power of x is equal to log a to the power of n into a to the power of x. Similarly, one more standard function is sine ax plus b. See, to find the nth differentiation of sine ax plus b, you take this function sine ax plus b as y. Let y is equal to sine ax plus b. You take that function. First you consider this function y is equal to sine ax plus b. Yes, now you take Now you differentiate this y with respect to x. Differentiate this with respect to x. Differentiation of y is y1. y1 is equal to differentiation of sine is cos ax plus b into a. Differentiation of ax plus b is a. You write a as it is. Now I wanted to rewrite this y1 is y1 is equal to a into, I think you know this formula, that is sine 90 plus theta can be written as cos theta, or cos theta can be written as sine 90 plus theta. So you write this cos theta as sine 90 plus theta, sine 90 plus theta means ax plus b. So again you differentiate this y1 with respect to x. Differentiation of y1 is y2. Why we are writing this y1 in terms of sine? Sine ಅಲ್ಲಿ ಯಾಕೆ ಬರ್ಕೊಂಡಿದೀವಿ ಅಂತಂದ್ರೆ, so if you are not written this in terms of sine ಅಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿಲ್ಲ ಅಂತಂದ್ರೆ it is difficult to generalize the result. ಫೈನಲ್ ರಿಸಲ್ಟ್ nth ಸ್ಟೇಜ್ ಅಲ್ಲಿ ಏನು ಬರುತ್ತೆ ಅಂತ ಬರೀಲಿಕ್ಕೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ I just write that cos in terms of sine. Cos ನ sine term ಗೆ reduce ಮಾಡ್ಕೊಂಡಿದ್ದೇನೆ. Okay. So now you take, once again you differentiate this y1 with respect to x. Then we get y2. y2 is equal to a into differentiation of sine is cos 90 plus ax plus b. This is theta now. Theta andre ಈಗ ಇಷ್ಟುನು ಆಗುತ್ತೆ, 90 plus ax plus b theta ಆಗುತ್ತೆ. Again you differentiate this 90 plus ax plus b, it gives a. Now you write y2 as, y2 ನ ಹೇಗೆ ಬರೀಬಹುದು ಅಂದ್ರೆ ನಾವು, so now you write y2 as y2 is equal to a into a square. So this cos can be written as sine 90 plus theta. Theta means this whole term is the theta. Theta ಅಂದ್ರೆ ಇಷ್ಟು ಆಗುತ್ತೆ. That is 90 plus ax plus b. So that is y2 is equal to a square into sine 90 plus 90 can be written as 2 into 90. 2 into 90 plus ax plus b. So by using y2 we can generalize the result. So y3 ಕೂಡ find out ಮಾಡಿ ಆಮೇಲೆ ಕೂಡ generalize ಮಾಡಬಹುದು, ಇಲ್ಲ y2 ನಲ್ಲಿ ಕೂಡ generalize ಮಾಡಬಹುದು. How it is? At nth step we have that yn is equal to, so you see this in y2 has a power 2. So ನಲ್ಲಿ y2 ನಲ್ಲಿ ಹೇಗೆ ಪವರ್ 2 ಇದೆ ಅಂದ್ರೆ yn ನಲ್ಲಿ ಹೇಗೆ ಪವರ್ n ಬರಬೇಕು. So you take n into sine. So you see in y2 we write it is 2 into 90. In y1 we write it is 1 into 90. y1 ನಲ್ಲಿ 1 into 90 ಅಂತ ಇದೆ. 90 ಅಂದ್ರೆ it is 1 into 90. y2 ನಲ್ಲಿ 2 into 90 ಅಂತ ಇದೆ. So yn ನಲ್ಲಿ ಏನಾಗುತ್ತೆ? It is n into 90. n into 90 plus ax plus b. So this is the nth differentiation of sine ax plus b. Therefore nth differentiation of sine ax plus b is equal to a to the n into sine n pi by 2 plus ax plus b. Similarly, we can find nth derivative of cos ax plus b. So you write cos ax plus b as, let y is equal to y is equal to cos ax plus b. Now we take its differentiation first. Differentiate this with respect to x. Differentiation of y is y1. Differentiation of cos theta is minus sin theta. So you write it is minus sin ax plus b into a. As I think you know this result, cos 90 plus theta. So that means it is in second quadrant. Second quadrant sin ಮಾತ್ರ positive ಇರುತ್ತೆ, cos negative ಇರುತ್ತೆ. So it is minus sin theta. So this minus sin theta can be written as cos 90 plus theta. So you can write y1 is equal to a is a constant, you write as it is. This can be written as cos 90 plus theta. Theta means ax plus b. So again you differentiate this with respect to x. Differentiate with respect to x. Differentiation of y1 is y2. y2 is equal to a into differentiation of cos is again minus sin theta, that is 90 plus ax plus b, close this bracket, into a. Differentiation of pi 90 plus ax plus b is a. Now we can write this minus sin theta as cos 90 plus theta. So that is y2 is equal to a into a is a square. Sin 90 minus sin theta can be written as cos 90 plus theta. Theta means this whole term is the theta, pi by 2 plus ax plus b. Theta andre ishtunu agutte. Okay. So now it is y2 is equal to a square into cos 90 plus 90 is 2 into 90 plus ax plus b. So by using this, we can generalize the result. At nth step or nth stage we have. So if we go on continuing like this, at nth stage, we obtain that yn is equal to a to the power of n into cos. Why it is n? A has a power 2 in y2. So in yn, a must has the power n. So y2 ನಲ್ಲಿ cos 2 into 90 ಅಂತ ಇದೆ. ಸೊ ಇಲ್ಲಿ 2 ಇದೆ. ಸೊ y ನಲ್ಲಿ n into 90 ಆಗುತ್ತೆ. So n into 90 plus ax plus b. Therefore, the nth differentiation of cos ax plus b is equal to a to the power of n into cos n pi by 2 plus ax plus b. You should remember this result. It is important to solve some standard problems, some problems. Okay. So this is the nth derivative of some standard functions. In next session, so I am discussing some more problems on nth differentiation. So okay, I want to stop this.